Here is another problem. So suppose that the final scores of a highly skewed distribution are taken. The mean of the final scores is 79 with a standard deviation of 10. So can we use the central limit theorem for means when we randomly select 10 scores? Why or why not? So a couple things. Notice that this distribution is no longer normal. In this case, now we have a highly skewed distribution. Okay, so that's, if we go back up here, we know that if the original population is normally distributed, then the size doesn't matter. So in this case, size is going to matter because we don't have a normal distribution. We don't have this. So size actually does matter. So we go to the step number 2, where it's not normally distributed, but we require n to be greater than or equal to 25 in order for me to use the CLT. So if I go back down, n in this case is 10, which is actually less than 25. Since 10 is less than 25, we cannot use it. Cannot use CLT for means. It's too small. The sample size is too small. We're not going to get something that's normal. Okay, so part B. Can we use the central limit theorem for means when we randomly select 40? Well, in this case, 40 is greater than 25, so yes, the answer is yes. We can use the central limit theorem for means because 40 is greater than 25, okay? All right, part C. Fill in the sampling distribution for the sample mean when you select 40 scores. Okay, and then round your answer. So in this case, so because we know that 40 scores is large enough, we know that x bar should be normally distributed with the mean of mu and a standard error of sigma over square root of n. Okay, so mu in this case is going to be my mean. My mean of these scores was 79, so we're going to put 79 here. And the standard deviation was 10, so it's going to be 10 over square root of n. And n in this case is 40, so it's going to be square root of 40. Okay, so we have x bar normal 79, and then we're going to put it in our calculator, 10 divided by the square root of 40, and what I got was square root of 10 over 2. So you press a button right above the enter sign and you get 1.581. Okay, since we want to round to 3 decimal places. Okay, so this is my sampling distribution. Okay, so now part D says, use the central limit theorem for means to find the probability that the sample mean score for the 40 scores was less than 75. So my mean here is still going to be 79. We want to figure out the probability that the sample mean of the 40 scores. Okay, so in this case, the sample mean of the 40 scores was going to be related to the sampling distribution that we found out in part C. So we want it to be less than 75. Here is 75, and we want this to be less than. So this is just our normal CDF, norm CDF. My lower bound now extends over to negative infinity. My upper bound is going to be now 75. My mean is going to be 79. And my sigma is going to be what I found here, which is 1.581. Okay. So I'm going to go to my calculator, normal CDF. The mean is 79. Sigma is 1.581. My lower bound is going to be negative infinity, so that's going to stay the same. My upper bound is going to be 75. And my answer is going to be 0.0057 or 0.006. So the probability of the sample mean score being from the 40 scores being less than 75 is approximately not even 1%. Okay, so now part E. What is the sample mean score? What sample mean score was the 70th percentile? Okay, so this is very different. We've done this before, but I think we haven't done this enough, so I wanted to recap this. So what I mean by 70th percentile, we know that the mean in this case was 79. We know what that is. We want to figure out what mean score will give me, so what x bar score will give me 0.7 area to the left. That's what the 70th percentile means. 70th percentile means that from the bottom is 0.7, from the top is going to be 0.3. And if you remember, in order for me to figure out what this value is, we don't want to use normal CDF. Instead, we want to use inverse norm. So inverse normal. And if you remember, this one you require the area to the left. We require to know what the mean is, and we require to know what sigma is. Okay, so in your calculator, it's very simple to use it. If you have the TI-36, all you got to do is press second data, distributions, and then press number 3, which is inverse normal. So let me go ahead and just write it right now. Inverse normal, inverse norm. My area in this case is going to be 0.7. My mean is going to be 79. And my sigma is going to be, what was it, 1.581. Okay, so I have a calculator right here. Okay, so if you have the graphing calculator, this is going to be good for you to see. If not, then just use a TI-36. It's just going to be the number 3. So we're going to press second vars. Okay, and then for those that have the other calculator, it's basically the same thing. You just will have inverse normal to be on your third one under distribution. So here's inverse normal. Okay, I'm going to press enter. The area in this case is going to be 0.7. My mean is going to be 79. And my standard deviation, or my sigma, is going to be 1.581. Okay, I'm going to press enter. And my answer is going to be about 79.8. This is going to be equal to 79.8. So this thing is going to give me, which is almost 80, so only 1 unit away, will give me a sample mean score that's the 70th percentile. So basically, all of the numbers are basically really, really close together. Okay, so that's my 70th percentile, 79.8. Okay, so make sure that you really follow the rules. The problems are very simple. They're just normal CDF or inverse normal. But as long as you have these conditions, you should be able to do these problems.